one, but I am going to run you through some of these questions real quick. So, question is 99 a good number for you? Is 99 a good number for you? What does that mean? You don't know? Why don't you know? What would you say? Is it a good number or not? No? Why? Yeah, I don't know. Okay. Just so you guys know, that's not okay. I'm not okay with the I don't know answer or the shoulder grunting. Okay, I'm going to keep at you until you answer me. So, for starters, the question goes to everybody. Is 99 a good number for you? Okay, a lot of times it might be, it might not be. Okay, because you can't really say much if you're just talking about 99. I don't know what you're talking about. Okay, I don't know if you're talking about I got 99 cars, 99 watches, 99 diseases. Depends. What are you talking about? Is it a good number or is it a bad number? Okay, so what we need to do is we've got to make sure that we attach meaning to our information. And that's the first unit that we're doing is in statistics. It's actually adding some meaning to what we're doing. Okay, we're not just going to throw that out there. So if I said 99 was your basketball score, then is it a good number?
Yes.
99 for its basketball score? Yes or no?
Yes.
Yeah.
Yeah, it's a good number. Okay, what about your golf score?
Yes.
No.
Not for golf. For
That's
golf,
high.
it's a little bit different, isn't it? Isn't it minuses that are good?
Yeah.
Okay, I don't play very much golf, but I know that it's supposed to be negative. So, okay, what about if it's your grade in, or sorry, your monthly salary,
No.
No.
your hourly salary
Oh, heck yeah.
in pennies?
No.
So it really depends, right? And what meaning you're attaching to that. So, what about your age?
No.
Actually, that's pretty cool. That means you live a long life.
As long as I can still clean my own booty, I'm okay with it. Okay, but if I can't, then I don't want to be 99. So the point is that we need to make sure that we attach meaning to our numbers. Okay, it's not about can you get the answer? Oh, what was the answer? 5. That means nothing. Okay, what was it? 5 inches, 5 meters, 5 bundles of hay, 5 cars, whatever it is. You got to make sure that you're attaching some meaning to that. So here's your first definition, which is statistics. And statistics is the science of collecting, organizing, and interpreting numerical facts, which we're going to call data. Gotta get an ID?
No, I switched a second.
Okay, well,
I had to switch my schedule around. I'm sorry.
it's all good.
Bye.
See ya.
Bye, Munoz.
Bye, have a good one. No, they went to a different class. But there's a lot of us still, same ones. That's a few. So few. And then some people went to band in the morning. Okay, so statistics is fairly new math. It hasn't been around as long as the algebra and the geometry. Algebra and geometry go way back. Way back. The beginnings of statistics only started in the 1600s by this guy named John Grant. And what he would do is he'd simply record how people died. And if you got some time, you want a couple of laughs, go look for the bills of mortality and read why people were dying. I mean, there's some really crazy reasons in there. Just funny sometimes. But anyways, there's going to be, in statistics, it's not going to be about can I get to the answer anymore. Okay? Because usually when we're doing math, it's about inductive reasoning. And there's 2 types of reasoning out there. There's the inductive and then there's the deductive. Okay? Deductive is when someone gives you a rule. Okay? And then you kind of make decisions based off of that rule. So, for example, if I said, hey, every Friday night I'm at Harkins watching the main event. So then if it's Friday and you want to know where I'm at, where am I going to be at? Harkins watching the main event. That's deductive reasoning. I've given you the rule. Okay? But inductive is different. No one gives you the rule. You kind of figure it out on your own, and then you make a decision based off of that. Okay? So, for example, if I'm saying, then what comes next? 5 claps. Okay, that's inductive reasoning. That's the difference between the two. Okay, in deduction, I'm telling you what the rule is, and you follow that. What happened?
Is this class AP stats?
No.
Oh, okay. I'm just making sure because I was like totally confused.
Same.
I was just making sure I was in the right place. You go ahead. You're good.
Okay, thank you.
Yeah, I got a little lost there.
Okay. Okay, so questions on those two, inductive versus deductive reasoning? Okay, deductive, you're given a rule and then you kind of figure it out from there. And inductive is, no one told me anything, I just kind of deciphered it on my own. One thing that you're gonna need to know is that answers are not gonna be made with complete certainty, and that happens because of human error. Okay, if we're working with data and we've got this huge list of numbers, sometimes you forget to put one in, or you type one in wrong, or maybe you get that math dyslexia. Anybody ever do that? You flip your numbers on there sometimes. It's like, oh shoot. So all the numbers are kind of off sometimes. Hopefully, we're going to strive that everybody has the same solutions, the same outcomes. Maybe different data, but always made with not with complete certainty. So one big thing here is you're gonna have to make sure that you explain yourself in context for this unit. Okay, and from this point on, always make sure that you're talking about things in context. Hey, what did you get for the mean? 6. Okay, that means nothing to me. 6 what? Okay, talk about the context. Okay, oh, there seems to be an average of 36 people in the classroom, in every math class or something. Okay, make sure that you're speaking within context, and use your common sense. Okay, a lot of math is just common sense. Variable, next definition. A variable we call any characteristic of a person or thing that can be expressed as a number or that it can be counted. A variable is any characteristic of a person or thing that can be expressed as a number or it can be counted. How many people in here take JROTC? Okay, I can count those number of people. Okay, how many people in here are boys? How many people in here are girls? Okay, how many people in here, I don't know, have blue eyes? How many people in here have a shoe size of 8, men's?
Oh.
I don't know. Those are all variables, okay? We can choose a variable to be anything we want, as long as we can express it as a number, or we can count it. Questions there? Okay. Data. Data are the numbers or the information that we collect in a study or experiment. And just so you guys know, data is plural. Data is plural. The singular form of data is datum, right at the bottom. So if I took everybody's age in here, and I wrote it down, all of the ages together would be the data. If I wanted to look just at Elena's number, then that would be called a datum. Datum.
Oh my bad, I didn't know you had a class right now.
Nah, I don't have a class. What do you need?
Wait, this is not.
That's not a class.
Oh, it's not?
Nah,
Oh, what?
we're just doing math for fun.
Wait, can you talk right now? Or?
I'm talking to you right now.
Well, I mean, private.
Oh. No. Sorry.
It's fine.
Because I'm in the middle of a class.
It's all good.
Okay.
I'll talk to you.
All right. I like him. He's funny. All right, cool. Now, there's two forms of data, two types of data. One is called quantitative. What? Well, it's only 2, okay? So make sure that you have only 2 down. You have quantitative data and you have categorical data. Now, here's probably what you wrote down, Trinity. The other name for categorical is called qualitative. Okay? So you might hear me talk about quantitative data or qualitative data, but there's only 2 types of them. One, I can count it where doing math makes sense, or I can just count them and know how many of them there are. Okay, where doing math does not make sense. Okay? Now the easiest way for me to tell is, if I can find an average and that average makes sense, then it would be considered quantitative, like a quantity, like a number. Okay? Qualitative is when you fall into a category and I can't really give you, I can't add the amount of people or whatever. So those are the 2 types. Here's some examples for you. Okay? If I'm talking about a rating system of superior, good, average, and poor, then would you consider that to be qualitative or quantitative? That would be qualitative, okay? It's a category, okay? I can't add up, these numbers. Well, for starters, they're not even numbers, right? They are definitely categories. So this would be considered qualitative data, okay? Are you good? Do you make good food? Or is your food, you make average, okay? You can only count them and put them into categories. So you have that. Another example, time in seconds to run a mile. Would you consider that quantitative or qualitative? That one's quantitative, right? I could take all those times, add them up, divide by how many, and find an average, and that would make sense, wouldn't it? Okay? So it makes sense here that I can do math. So that's definitely quantitative. What about social security numbers? This one's a weird one. That one's qualitative, okay? Because a social security number, I can't add up the social security numbers and find the average social security number, right? That doesn't even make sense, okay? Social security number is actually qualitative because it tells you, for the first few numbers, tell you what state you were born in. The next two numbers tell you what county you were born in. And the last numbers tell you what hospital you were born in. So it's definitely qualitative. It's taken from state to county to which hospital, okay, which are all categorical in nature. How about students' tests ranging from 1 to 100? Quantitative, qualitative, Taurus. Yeah, why? I think she knows.
Because it's not in a category.
You hear that, Taurus? What? It's not in a category. And doesn't it make sense that I can find the average grade? Does it make sense that I can find the average grade of this? Yeah, from all the scores in the test. So yeah, that's definitely quantitative. What about the heights of people in inches? Quantitative, quantity. Okay, because I can find the average height, couldn't I? Okay, on average, people are this high. Okay. How about zip codes? I've got codes. That's definitely qualitative. Okay, that tells you where you live, right? That's it. I can't find the average zip code. That won't even make sense. So, how about the percentage of students in a class who master a particular skill? That one's qualitative. Either you mastered it or you didn't. See how it falls into one or two categories? So, think categorical would be qualitative. Okay? If I can do math with it, how would I do math with mastering a skill? See what I'm saying? It's kind of weird. Now, could we make any one of them fall into the other category? I think you could. It depends on how you ask the question. So we could definitely do that. But the way these questions were asked definitely falls into one of those two categories. Now, here's an example of how qualitative data cannot be quantitative. Okay? So here's what I did. Wow, on the slide anyway. If you're white, I assigned you a number of 1. If you're African American, you got assigned to 2. If you're Asian, you got assigned to 3. And if you fell into this other category, you got assigned to 4. Make sense? Simple enough? So, what happened? You fall into other? Okay. So anyways, when I take a look at how many people I've got here, I've got 60 people. Okay? So I found that the average was 1.98. So the average person is African American, right? From this group of people?
No.
It's not? But I did the math right. Well, it's not right because you can't do that for starters. You can't do math when it's categories. Even though I assigned the numbers, that's just wrong. Okay, you can't do that. I can find the proportion of each, but I can't find the mean. Okay, I can say, 23 out of 60 people are white, 19 out of 60 people are African American, 14, so forth, so forth, so forth. So I can find a proportion of categorical, but not the mean for categorical. Okay. So again, we're trying to make sense out of data. We're trying to make sense of this information. If you remember the answer, don't say anything. But here is, and this can actually happen in any county that you look at. Okay, so no matter where you go, look at the number of tickets that are issued. If you're 35 years and older, they have a total of 15,000 tickets. If you're under 35 years old, then you had 10,000 tickets. So it looks like older people get more tickets, right? But here's the deal. If you're younger, you pay more in insurance. It's a fact. The younger you are, the more insurance you pay. That doesn't seem very fair, does it?
It's fair.
It's fair?
Yeah.
So, because you're younger and you have less tickets, you pay more insurance,
Well, because older people have had a time to establish their history, like,
but they got more tickets.
because they're older. They're older, so they've had more time to get tickets.
I see what you're saying, but this is in 1 year.
Oh,
So this, yeah. So thank you. That was great. So we're making sense of this, right? So this is in 1 year. This is what they found: 35 years and older, 15,000, and then in 1 year, under 35 was 10,000. What do you got?
Is it because more people there's more people driving over 35 than under 35?
That makes sense.
yeah,
That didn't make sense.
because from ages 1 to 16, you can't drive.
Ah, okay, that makes perfect sense.
So
Did everybody catch
there's-
that?
So there's less people driving.
Yeah. So even though this says under 35 years old, what did you say it was 1 to 16?
It's, yeah, it's 16,
They're not driving.
It's really 16 to 35.
Okay, so you really have 16 to 35, don't you? So that's a lot more tickets than those that are 35 to death, right? So, good. This kind of made me bummed out when I saw this. Half of the kids in the U.S. are below the national average in mathematics. Half of the kids are below the national average. You believe that, dude?
Yep.
I believe it. That's true. Not you?
I'm nice.
You're nice?
I'm nice.
Nice. So, explain that to me.
Like, what do you want me to explain? Why kids are?
Why
below
half the kids are below the average?
Well, because like the way they measure that stuff is by testing, right?
Right.
Yeah, most kids don't give a crap about testing. Like from what I hear, most of these kids go into the Galileo test and just click answers.
Oh, don't tell me that. That breaks my heart.
Yeah, that's what I hear.
Yeah.
That's what I hear all the time.
We're actually reading beyond this, okay? Whether they tried or they didn't try, half the kids are always going to be below the national average. Okay? This is why. Let's say that's the distance of my distribution, okay? Where's the average?
Middle.
Where?
The middle.
In the middle. When is it ever not in the middle? So aren't half the kids always under the average?
This is like an aptitude test.
No, this is just baloney. Okay? Half the kids are always going to be below the average because the middle's always in the
Oh, I see what you're saying.
middle.
Yeah.
Okay? So, it's just baloney. It's just, ha
So in order for well, back to that. So in order for the kids in order for half the kids not to be below the average, they'd have to move the average back.
But then wouldn't they, half of them still be below?
Don't overthink it,
Would
Caleb.
they be over? Because
Well, you can always say half the kids are over the average,
yeah. You
but it's
can
always
say-
going to be half and half because where's the average?
No, I'm saying like if you move the average from the half, like move it back, when more kids be above it,
But then
like
it's not an average.
But yeah, that's on an average.
It's not an
that's
average.
crazy. Like that makes no sense.
It's not supposed to. Okay. Should we move on?
Yeah. You
All right, so-
my bad.
This one's a really weird slide. I think it's kind of funny.
Yeah, it is funny.
Look, blowing kisses. But anyways, these are this actually came from a research article, and they're talking about death by drugs a year. Okay, and they had tobacco at 400,000 people dying. Alcohol was 90,000, cocaine was 8,000, heroin is 6,000. Now, if you're just looking at this, you're like, man, dude, I'm gonna go use heroin because less people die.
Nah.
So if you take heroin, like, isn't that's
No,
true though?
dude.
Is this
All
true?
right, here's the thing. I don't know where to get heroin from, but I know where I can get some cigarettes from.
I know where I could get, never mind.
We're gonna move
I
on.
was gonna say cocaine, but.
But you know what? That's
Shouldn't say
but
that.
that's you know what, and that's just a fact of life. It's just true. I mean, where we live, who we know. I'm sure that everybody knows. But what this is kind of saying is that you know what? If you're gonna pick a drug, not I'm saying that you will. You know, heroin, less people die from it, right?
No.
No, not necessarily. So we're trying to make sense of the facts, okay? Maybe 6,000 people is everybody that uses heroin. So this might kill 100%. Oh, that's horrible.
Yeah, because billions of people use tobacco. Like.
Right. So maybe this only kills 3% of its population. Okay? So you really have to be careful what your numbers are, okay? And we know that at a glance is misleading, okay? But that's the point, is what we don't want. We want to be able to make sense of what people are telling us and look at all the other facts and the common sense, okay? Does 100% of people do heroin?
No.
Oh, wait a minute. 100% of people that do heroin. Never mind. That doesn't sound right at all. Less people do heroin than people that smoke tobacco. So, but it kills less people because it only kills 3% of people who use it. Versus it kind of be habit.
Have you ever thought about doing cocaine or heroin?
Nah,
It's not.
not really.
That's like the stuff your parents like grow up telling you, don't do that. Say no
I've
to
never
drugs,
really
like-
felt the need to. Like, why?
Yeah. No, I don't.
I want to go do something that could kill me. Yay.
Anything.
Really. No one's ever even offered me heroin. Like, I don't even know where you would get it. That just sounds like so far off.
All right, guys. Have a great day. I'll see you tomorrow. Not today. That's your notes. Hold on to those. So we're gonna start with some definitions real quick.
What chapter is this? What chapter is it?
This is, I don't remember what chapter it is, but it's a sampling distribution. I believe
Wait,
it's,
is it on the bottom? Is it that thing on the bottom?
no, that's old.
Sampling distribution?
Sampling distributions. Sampling. Yeah, 7. Oh, nice one. Sampling distribution. Okay. So just some